is independent and the multiplication rule. Independent event, that means the event E, the occurrences of the event E will not bother or does not affect the probability of the event F. So the multiplication rule for the independent event, if the event E and the F, they are independent, then finding the probability of the event E and event F, you just simply to multiply the probability of two events. And we went over this example in the class yesterday. So finding the probability of the female age 60 old, the survival rate is this percentage. Now, if you are looking for two randomly selected female at that age group, what would be the probability of the survival rate of the two female? You just simply to multiply the first survival rate of the female to multiply the survival rate of the second female and multiply them together. That would be the probability when you are looking for two female at that age group 60, the survival rate of that year. When you are looking for more event and they are independent event, finding the probability, you just simply to multiply the probability of each event. Multiply them all together, that would be the multiplication rule of the independent event. At least one. At least one, the mean has one or more. The probability has one or more than one. So to find the probability of at least one of something, we calculate the probability of none and then subtract the result from 1. And then that will be the probability of at least 1. So the formula to finding the at least 1 probability, we use the 1 because this is the total sum of the probability to subtract the probability of none. That will tend to at least 1 probability. So we look at this example. Top 4 supplies X data DVDs in lots of 50. They have a reported defective rate of 0.5%. So the probability of a disk being defective is 0.005. It follows that the probability of a disk being good is 9.995, right? When I use a 1 to subtract 1 to minus 0.005, you'll get a 0.995. So 0.005, this is a defective rate. That means 0.995 is none. Is good, right? In other words, it's a good product. So being good product rate would be 0.995. What is the probability of getting at least 1? At least 1, this is a key word. Defective disk in a lot of 50. That means they are running the test 50 times. So when you're running the test with 50 times and they want to find at least 1 defective disk. So we use a formula. Write down the formula, the probability of finding at least 1. At least 1 defective item, right? Defective item. We just simply to use the 1 to minus the probability of non-defective item. So non-defective, which is, this is the same meaning as a good. There's nothing wrong with the item, right? That will be the probability of the good item. So we know the good item, which is non-defective rate, is 0.995. Now we have to multiply this probability with power 50 because you multiply it in 50 times. So when you do the calculation, 1 minus 0.995 to the power 50, you will get the number is 0.7778. So when you subtract from 1, the result here, that represent when you run the test 50 times, and the chance you might get at least one defective item would be 0.222, which is 22% of the chance you will get at least one defective item if you are selecting the disk from the lot of 50. I hope that makes sense to you. So here you just simply need to remember the formula finding the at least one probability. We use the 1 to minus the probability of none. And then you're finding at least one probability. And keep in mind, getting the at least one probability, at least one probability, your experiment must be independent event. Right? That's only possible way you are getting the at least one probability. If the two events they affect to each other, there's no way you'll get at least one. We look at another example. The probability that randomly selected female, the same example from the previous slide there. They are age 60 years old. Survival rate is 0.99186 according to the report. What is the probability that at least one, right, this is a keyword, of 500 randomly selected 60 years old female will die during the course of the year? So finding the probability at least one dies, we use the 1 to minus the probability none die, which is they'll survive. And the survival rate for the age group at 60 of that year is 0.99186. Now they are running the test for 500 female. So we need to do the power 500. In other words, you multiply this survival rate 500 times. And that's the same meaning you do the power 500. This number to the power 500, you turn to the 0.0168 approximately. When I use a 1 to minus 0.0186, it turns to 0.9832. So this probability represents at least one female of age 60 years old will die. At least one will die of that year. When you do the test of those among those 500 female. Now we summarize the rule of the probability. The probability of any event must be between 0 and 1. If we let the E denoted any event, and the probability of the event E must be between 1 and 0. It could be equal 0, could be equal 1, but that would be the interval. That's a range. The number must be between 1 and 0. There's no way you get a negative probability. The sum of the probabilities of all outcomes in the sample space must equal 1. That's a probability model. That is, if the sample space, you sum it all together, for sure you will get a 1. If E and F, they are disjoint event, then the way you finding the OR event of the probability, you just sum them all together. When they are not a disjoint event, finding the OR event, you use the probability of the event E plus probability of event F, and then you minus the parlay overlap. Remember that we use the diagram, Venn diagram in the class. So you have to subtract the parlay overlap. So this is event E, this is the event F, and the middle overlap region here, that is the probability of the event E intersect with the event F. If event E represents any event and the E to the power C, we call that it's a complement event. So the probability of the complement event, we just simply to use the 1 to minus the probability of the event E. If E and F, they are independent events, then finding the probability of both events, we multiply them together because they don't affect each other. Finding at least one event, we use the 1 to minus the probability of the none. And so this is the same meaning. You are using the 1 to minus the probability of the complement, right? So that's the same meaning. You are finding at least one event. But I want you to just use this one, to memorize this one. Then you will not go wrong. Right? This is not a good strategy to remember this one. Alright, so this is section 5.3.